Let's discuss question number 12 from test 3 machine. It's a question from machine design, basically maximum principal stress. Well, okay, you can say SOM as well. Okay, so a thin walled cylindrical pressure vessel. Okay, and the thickness is very small, is subjected to internal pressure. So basically the internal fluid pressure P is given as 6 MPa. The inside diameter is 50 500 mm, and thickness of the vessel is 13 mm. Now maximum principal stress in the vessel. Okay, now if you take any element on this, you have the circumferential stresses, basically the hoop stresses, as well as the longitudinal stresses, because the ends are closed and the fluid enters from the opening somewhere in the circumferential location, but the ends are closed unless otherwise specified. So you have these two stresses that is set up on any element, the circumferential stresses and the longitudinal stresses. Now the circumferential stresses, when we get by the force balance, we get it PD by 2T. PD by 2T is the circumferential stresses. We just cancel. The circumferential stresses is pressure diameter by 2T, whereas the longitudinal stresses is pressure diameter by 4T. Now this you will get it from by just taking a section at the circumference, and then the force balance, the external force being the due to the pressure, and the internal force between from one part to the other part. Okay, so all that basically taking a section in the circumferential and in the longitudinal direction, you get expressions for circumferential and longitudinal stresses. Okay, now when you have a 2D thing and you have this normal, only the normal stresses on the perpendicular faces, and you don't have the shear stresses, the maximum principal stress is the maximum of these two. The maximum principal stress, this we have seen in, is basically the maximum of sigma C and sigma L, and that is nothing but sigma C because of by 2T. So this is PD by 2T, which is pressure is 6 MPa, diameter is 500 by 2, thickness is 13. So mm gets cancelled, you will get everything in terms of MPa. So 115.38 MPa. So the answer is 115 MPa. So this is fairly a simple problem. Answer is B. Thank you.